Hello student, my name is Nimesh Prabhakar. I am Assistant Professor at LJ Institute of Engineering and Technology in Instrumentation and Control Department. Welcome to Process Control lecture series.
In my previous lecture, we discussed about the multi-capacity process and dynamic behavior of the system with date time. Now, in this lecture, we discuss about the inverse response of the system. Now we see the inverse response. So, before we understand the inverse response, we even take one example of the car. We all know when you push down your car's accelerator, you accept the car to speed up, right or wrong. That means when we push this accelerator, that at that time the speed of the car is increased. Okay, right or wrong? Right. But actually, what if slow down? That means to increase the speed, we push this accelerator. But actually, it happen the car speed is reduced. That means we try to increase speed, so we push this accelerator. But actually, it acts as a opposite. That means the car speed is reduced when we push this accelerator. And in opposite side, when we leave this accelerator, at that time the car speed is increased. That means opposite effect. When we press, at that time car speed is decreased, and when we leave this accelerator, at that time the car speed is increased. Or even worsen, you left your foot off the accelerator and your car speed up. And the more you lift your foot, the more the car speed up. That means is opposite. So these are almost unthinkable, we know, and certainly scary situation. Yet they occur every day in thousands of boilers and some other process around the world. So this type of situation occur every day in the boiler. So the phenomena is known as inverse response. So this type of phenomena is known as inverse response. Inverse, that means opposite type of response. Here we try to increase the speed, but actually car speed is decreased. But when we try to decrease the speed, at that time car speed is increased. So here the opposite effect occurs. So this type of phenomena is known as the inverse response. Now, one of the most common occurrence of the inverse response is found in the control of boiler drum. So now we understand the inverse response in terms of water drum. So here in the figure, a representation of the simple drum boiler. So consider the simple drum boiler shown in the figure. So this represents the drum area of the boiler, and this represents the input of the water. That means the inlet water line. So from this line we give the water, and this is the generation of the heat. So first of all, we understand what is the function of boiler. So simple function of boiler is to convert the water into steam. In another word, we can say boiler used to generate the steam. That means it simply convert the inlet water, this means this water, into the steam. That means here we give input as a water and we get steam as a output. So this is a simple function of the boiler. So now this is a boiler drum, and to convert this water into the steam, here we give the heat. So this symbol is represent the heat supply symbol. So here we give the heat. Now here we understand the inverse response. This is the indicate the level indicator. That means the how much water in this drum it indicate by using the level indicator. This is the transmitter, and this is the water level controller. That means if water level decrease or increase, this controller is open or close this feed water valve and control the water inside this drum or inside this tank. So now we understand the inverse response of the water. So at initial state, when the boiler is working, so at that time when we add this cold water, we know inside this boiler drum water is of course more compared to this water. That means this water is cold water and inside this water is the hot water. So temperature of this water is more compared to this water. So when we add this cold water into this hot water, so at that time suddenly the temperature of this water is decreased. So due to that the bubbles over this water is reduced. So at that time level indicator indicate false reading. That means it indicate the water level is reduced. So this is known as inverse response, because here we add water but level indicator indicate the water is reduced. So that's why it's known as the inverse response. So if flow rate of the cold feed water, if the flow rate of the cold feed water is increased by a step, the total volume of the boiling water and consequently the liquid level will be decreased for the short period, and then it will start increase as shown by the response in the figure. Here this three line indicate the response. So this is the overall response and this is a normal situation response. But when we give as a cold water as an input in this system, so at that time initially this response, that means the water level inside this drum is reduced. So this graph is indicate the decreased level of the water level inside this tank. So this is the decreased level. Liquid level will be decreased for the short period of time, and then when this inverse response effect is gone, then it goes to the here. So this is the overall response. So this is the mathematical representation of this system. So net result of two opposing effects can be examined as the cold feed water cause temperature drop, which decrease the volume of the entire vapor bubbles. This lead to decrease of the liquid level of the boiling water following first order behavior curve, that is this. That means this block is represent the inverse response of the system. That means here this line, this curve 1 is represent the inverse response. That means when we add the cold water, at that time initially it decrease the drum level of the boiler. So this block is represent the inverse response, and with the constant heat supply the steam product remain constant, and consequently the liquid level of the boiling water will start increasing in the integral form, leading to a pure capacitive response. That means this represents the pure capacitive response of the system, and due to that this effect is for the only for the short period. After this short time, this overall response is increased. That means this is the integration of these two systems. That's why it's called the integral system. That means it initially, due to this inverse response, it decreased, but after we giving the heat and as a constant supply, that time it will be come at the increasing level. So this is the overall response of the system. So this is the mathematical model of this boiler drum system. Here this block is represent the inverse response block, and this is represent the continuous heat supply block. And so the overall transfer function can be written as, so here we connected this block in a parallel form, and we know as per the rules of the block diagram, if we connect two blocks in a parallel, so overall response is the summation. So y of s upon f of s is nothing but the summation of these two blocks, but this is an inverse block, that's why here we indicate the minus sign. So K2s minus K1 tau 1s plus 1. So this is the overall response of the system. So we can simplify this equation as, and we can write this equation as the K2 tau 1 minus K1s plus K2s tau 1s plus 1. So this is the final equation of the overall response of the system. This equation is true for condition tau 2 is less than, K2 tau 1 is less than K1. The second term minus K1 upon tau 1s plus 1 dominate initially, and we take the inverse response. So if the condition above is not satisfied, then we do not have inverse response. So if this condition is satisfied, then and then we get the inverse response of the system. If this condition is not satisfied, then system is in the system there is no inverse response. So in the simple word we can say, for the condition for the inverse response, the transfer function poles value is positive. We know the zeros and poles, we know the zero and poles. So for this system has the inverse response, so condition for that the poles, zeros has positive value. That means these zeros, it has the positive value, then and then this system has the inverse response. If the zeros has negative value, that time this condition is not satisfied. So that system is does not have inverse response. Now to understand more, we take the another example, inverse response of two opposing first order system. So this is the first order system 1 and this is the first order system 2. So here we connected this system but in a opposing manner. That means here this is a plus and this is a minus sign. So this is the response 1, process 1 response indicated by dashed line, and this is the response of the process 2 indicated by this dashed line, and this is the overall response. That means this second block is represent the inverse response. Due to that, this inverse response effect is occur. So the figure show two opposing effect result from two different first order process. The overall transfer function can be written as y of s, this is a y of s upon f of s is equals to the summation of these two process k1 tau 1s plus 1, and here the minus sign, so that's why it is a minus k2 tau 2s plus 1. So by simplification we can write this equation as k1 tau 2 minus k2 tau 1s plus k1 minus k2 upon tau 1s plus 1 tau 2s plus 1. So here from this graph we can conclude initially at that t is equals to 0 plus the process 2 which react faster than the process 1. This process 2 is react faster than the process 1, dominate the response of the overall system. That means here it indicates the negative response initially. Now, but after some time, ultimately due to this process 1 reach a higher steady state value than the process 2, and the force, the response of the overall system is opposite direction. That means here due to the process 2 this response in the negative direction, but due to this process 1 this go in the positive direction. So overall response goes in the positive direction due to this process 1 response. So here same as condition, when tau 1 upon tau 2 greater than k1 upon k2, the process exhibit the inverse response, and we find the system transfer function as a positive 0. So this is the condition for the first order, condition for the inverse response of the system. So here we see the inverse response.